All right, so in this lesson here, we're going to be taking a look at surface area of basic shapes. We're going to be starting with what I would consider to be area of 2D shapes, and then we'll move into surface area of regular or basic 3D shapes, specifically prisms. Now, all these equations are on your formula page, and you can take a look at that as well. And we'll, again, we can go over those a little bit later on. I will show you copies of the formula sheet that you can take a look at and that you can use as well. So let's start off with just surface area in general. Area or surface area I use for 3D shapes, is really important in many areas of life. We use it especially in the construction and design industry, and we're going to put those in here right now. To kind of find cost estimates as well as product takeoffs. Like I said, many cost estimates for projects are based on the surface area, and the surface area of many things affects the way that they work, whether determining the rate someone can cool or the amount of surface which can be used for intake or pouring, depending on the type of product that we're dealing with. To find surface area, okay, I have some basic calculations that we're going to use, and then we're going to move to a little more practical and complex shapes as well. So let's take a look at some regular 2D shapes. First one we're going to take a look at is our basic rectangle. Well, a rectangle, we have two measurements. We have the length in L, and there is the width, or W, which you would usually have as well. Now, to find the area of a rectangle, we use our formula, A. I use A for area and SA for surface area. We'll get the surface area in a little bit. Area equals length times width, or L times W, and that's going to give us our area. Now, some of you have also seen base times height potentially as well. You can use B for base. I'll call this we'll say that this is the base. I'm not trying to confuse anybody here, and we'll call this the height. Okay. Some of you have seen those as well in the past. Okay. Whatever you're using, it's the two sides being multiplied together to come up with our area. Square, on the other hand, okay, is a rectangle. Yes, crazy things, right? A square is a rectangle. It is a four-sided shape with 90-degree corners, where the opposing sides are the same length. The difference is that the fact that a square, and I'm going to actually use B for base in this case here, has four equal sides, and they're all the same length. Let's use L for length. And it looks kind of like a 1, but use L for length. So to find the area of a square, we do area is equal to length times length, because it's the same, or we can say that as length squared. Okay, it's a square, so we're able to use that kind of just square it. Just take one number and square it. Those are very basic shapes. We've done those in the past for many years, and we understand how to use those. A parallelogram is maybe a little bit different, where you may or may not have seen some of it before. So a parallelogram, and we're going to draw in a measurement right here in green. And I'll try to switch it to a dashed line, just so that it is a little bit, there we go. Okay, there's my dashed line. A parallelogram has parallel sides to it. And let's draw those in as well. So this side, do two arrows, is parallel to this side here. Okay, those little arrows meaning parallel. And this side up here is parallel to this side down here. Okay, that is a parallelogram. A rectangle is also a parallelogram. It's just a little bit of a different parallelogram. It has 90-degree corners instead of multi-way corners here. What we have is we have two measurements. We have a height right there, and the top and the bottom, I'm going to put it on the top, is going to be our base length. So that's the top and the bottom, and then the height is from the bottom to the top. Okay, so that's how we're going to look at our height. And to find the area of a parallelogram, it is exactly the same as a rectangle. It is base times height. Simple and straightforward. Parallelogram is simple and straightforward. All right, let's move to slightly more complex ones. Let's take a look at a trapezoid. A trapezoid has parallel top and bottom. Okay, we're going to put that in there. This line right here is parallel to this line right here. And it's important that we show that. We also have, in this case here, a height, which is 90 degrees from top to bottom. And again, I'm just going to make that into a dashed line. There we go. There's my dashed line. And that right there is our height. Okay, so let's put a height right in there. Now, a trapezoid has two different dimensions. It has this top side, which we'll call little b, and it has this bottom side, which I'm going to call big B. To find the area of a trapezoid, we need to find the average of these two right here. So we need to find the average of the top and the bottom. So our area is going to be our little b plus our big B. There we go. And we divide it by 2. Then we multiply by the height. So find the average of little b and big B. So little b plus big B equals divide by 2. And then we multiply that by the height. And that's going to give us the area of a trapezoid. Now, we don't take a look at a lot of trapezoids. Those are a little bit more uncommon, but they could come up. And so I want to make sure that you have the equation for that. Okay. On the formula page, you'll notice that I give a trapezoid as well. So you have the trapezoid. It looks a little different. It's multiplied by half. You can just divide those by 2 as well. It's the same thing. Circle. Now, many of you know how to find the area, or I've used the area of a circle before. We're going to start off with looking at the two measurements that we have. The first one is one that goes all the way across, and the second one is one that goes from the middle to the outside. And we're going to put those into different colors here. The one that goes all the way across is little d, which we call the diameter. And the one that goes only halfway is little r, which we call the radius. We have one other measurement in a circle, and that is, I'm going to call big C. That is our circumference. That's the perimeter all the way around, or the distance all the way around. To find the area of a circle, okay, again, radius is halfway, diameter is all the way. Okay, the area is equal to the little pi symbol, okay, r squared, which is the same as pi times r times r. Okay, you can think of it that way as well. So it's pi times r. That is to find the area. It's our pi symbol, which you can see on your calculators, or you can recognize as being 3.14 times the radius squared, or the radius times radius. Okay, it's not radius times 2, it's radius times radius. Be very careful about that. The other thing that we might need for a circle is what's called a circumference, or the perimeter all the way around. Now, many other shapes, we're just adding things together to find the circumference. Or the perimeter circumference is a little bit different. It's pi times the diameter, which is also equal to 2 times pi times the radius. Okay, they're exactly the same. The diameter is just 2 times radius, so we have that in there, and so we can find the area, sorry, the circumference of a circle if necessary. Next shape we're going to take a look at is a triangle. And a triangle has two measurements that we need to know, at least for area. Number one, we need to know the base length, as well as we need to know the height of a triangle. And this right here is the height of the triangle. Put that in there. Okay, so this is our height right there. It is the distance from the peak to the base. And this right here is the base, the distance all the way along. That is our base. To find the area of a triangle, it is base, let's put this in the brackets here, base times height divided by 2. I'm going to get rid of those brackets because we don't really need them. I just need them to type that in. So area is base times height divided by 2. It's important that we recognize that this height right here is, again, a 90-degree corner to the base. Okay, so from peak, 90-degree corner. Now I want to show you another example of a triangle. This is a right angle triangle. A right angle triangle is exactly the same as a regular triangle, except that the height is now on the outside. This is the peak of the triangle, and this is the base. And so there is a 90-degree line that goes from the peak to the base, and that is the height. this case, it's one of the outside pieces of our triangle. Again, area is equal to base times height divided by 2. There we go. Okay, and so it's exactly the same. A right angle triangle is exactly the same. We're going to take a look at a lot more right angle triangles a little bit later on when we get into trigonometry, but for now, just recognize that it's base times height divided by 2 to find our area. If we want to do the perimeter, we have to add up all 3 sides. The last one that I'm going to look at is something called a polygon. We're going to think of this as a regular polygon. A polygon can have any number of sides. This one here has 8. And what I want you to think of it as is that you can divide a polygon into a bunch of equal triangles, okay, by connecting opposing corners. So there we go. Look at that. We made it through the center all at the same time here. Okay, so these are a bunch of regular triangles. Now, if we can find the area of each triangle, we can and then multiply it by the number of triangles that we have to find the area of a polygon. And you will have a few questions on this, and I do throw a bunch of them on there. I really do like the questions that deal with a polygon. What we need to know is we need to know this length right here. Okay, so this length right here is what goes from the center to the outside. In a circle, we would call that the radius. Okay, in a polygon, we call that the apothem. Okay, and I'm just going to put a little a there. A is for apothem. Do that right beside. Okay, I'm just going to write that out. Okay, something called the apothem. So it's equal to the apothem. So we need to know what this distance is from the middle of one side to the center. There's our apothem. The other measurement that we need is the base length, and that's the one length of a polygon. Okay, so one side of a polygon is the base. And then the other thing that we need to know is what's called n, and that is the number of sides. In this case here, we have an octagon, which is 8-sided, and so we know that it is that it's 8. Our formula for this here is the area of a triangle times by the number of sides. So our area is our base length times our apothem, and then divided by 2. But we're actually going to do our number of sides as well, and then we're going to divide the whole thing by 2. So to find the area of a polygon, we do the base length times the apothem times the number of sides, and then we divide that by 2, and that's going to give us the area of a polygon. This part here, BA over 2, is our triangle, N is the number of sides, but we can just multiply that all together in one shot. Now, using that understanding and that knowledge, and you can also use your formula page for area, I want you to do questions 1 and 2 on the assignment. It's looking at area of 2D shapes.